In this quick tutorial, we'll see how to deserialize a JSON document with Arduino JSON 7. As a reminder, deserialization turns a JSON input into objects from which we can extract the values. This tutorial requires a basic understanding of Arduino programming and a vague knowledge of JSON. It doesn't matter if you're using an Arduino Uno, an ESP8266 or an ESP32. The code shown in this video works on any device. Let's jump right in. Here is the skeleton of our program. Like most Arduino sketches, it starts by initializing the serial port. Then it defines a string that contains the JSON document we want to deserialize. In this case, the JSON input is hard-coded, but in an actual project, it will come from an HTTP response or a configuration file. This JSON document contains three root members: a string named sensor, a number named time, and an array named data. Then, these lines extract the four values. As you can see, they are incomplete, so we'll have to fix them. Finally, the program prints the values extracted from the JSON document. Now, we must fill the blanks and make this program work. Let's start by installing the library. Click on the Library Manager tab, search Arduino JSON, click Install. The library is now installed on your computer, but to make it available in the program, we must add an include statement at the top. Then, we must declare a variable to store the deserialized document. We do that with JSON document. Then, we must call deserialize.json, passing the JSON document as the first argument and the JSON input as the second. We can now extract the values from the JSON document. Let's start with the sensor string. As you can see, we use square brackets to extract a member from a JSON object. Arduino JSON implicitly converts the values to the expected type. We can do the same with the timestamp. If you don't like implicit conversions, you can explicitly set the type with AST. I think the implicit conversions are more suitable in this case, so let me undo those changes. Finally, you can chain brackets to extract nested values. For example, we can extract the coordinates like so. Here, we are extracting only two values from the data array. But if we were to extract many values, it would be more efficient to save a reference to the array. As you can see, we use JSON_Array to hold the reference to the array in the JSON document. This is more efficient than the previous version because the program only searches for the data key once. Also, JSON_Array allows you to perform loops. As you can see, the item in the for loop is a JSON variant. Like JSON_Array, it is a reference to a value in the JSON document, except JSON_Array is limited to arrays, whereas JSON variant can refer to any value. It is crucial to understand that neither JSON_Array nor JSON variant hold any data. Instead, they rely on the JSON document to have it. Therefore, you must never use a JSON_Array or a JSON variant after the JSON document has been destructed. Note that there is a third reference type, JSON_Object, similar to JSON_Array but for objects. I invite you to check the documentation to learn more. Anyway, we don't need a loop in this program, so let me undo this change. At this point, the program should run and print the values. Let's try. As you can see, it prints the values as expected, but are we done yet? No, we forgot an essential part, the error handling. Let's go back and fix this. Two kinds of problem can occur in this program. The first kind is an issue with the deserialization process. For example, the JSON input could be invalid or we could run out of memory. We can easily detect these problems by checking the return value of deserialized JSON. As you can see, deserialized JSON returns an error status of type deserialization error. We can test if the call failed with if error. If that's the case, we can show an error message. As you can see, we can call cstr to get the string representation of the error. Let's add a return statement to skip the rest of the function. The second kind of problem is when deserialization succeeds, but the document differs from what the program expects. For example, some fields could be missing or have a different type. In both cases, Arduino JSON returns a default value that depends on the extracted type. For example, if the member sensor is missing or if it's not a string, Arduino JSON will return a null pointer. In other words, the variable sensor will be null, so you may need to prepare for this possibility. Similarly, if the member time is missing, Arduino JSON will return 0. You can change the default value using the pipe operator. For example, you could define a default for sensor like so. Now, if sensor is missing, or if it's not a string, the variable will be assigned to unknown. Note that this particular use of the pipe operator is specific to Arduino JSON and only works with JSON document and JSON variant. That's better. So, as you saw in this tutorial, a significant part of the code is dedicated to extracting the values from the JSON document. Writing this code can be cumbersome and error-prone, which is why Arduino JSON offers a tool to generate this code for you, the Arduino JSON Assistant. The Arduino JSON Assistant is available on arduinojson.org. Click on Assistant at the top. First, select the device you're using. I'm going to select Arduino Leonardo. Then select the deserialize mode. Finally, select the input type. It was conchar star in our example. Now, click Next. In the input area, enter your JSON document. As you can see, our example has already been filled out. At the bottom, we can see some gauges to check that the JSON document fits the hardware and software limitations. Click Next again. This last step contains a sample program that extracts all the values from the JSON document entered in step 2. Alright, that's all for this quick JSON deserialization tutorial. If you enjoyed learning from it and want to expand your skills further, consider checking out the full-length guide in my book Mastering Arduino JSON. Not only does it offer an extensive exploration of various aspects of JSON processing with Arduino, but purchasing the book directly supports the development of Arduino JSON and the other libraries I created. If you have any question about the library, first look at the extensive documentation on arduinojson.org. If you cannot find the answer, please open an issue on GitHub. You will find the link in the video description. Thank you for taking the time to watch this video to the end. Now stop wasting your time on YouTube and go write some code.